grade, 5th grade, I don't know. You were able to find greatest common factors between two numbers. So let's say I have the number, I don't know.
9.
No, let me make up my own mind. Thank you. 12 and 28. How many different ways could you make the number 12?
It would be like 3.
You could
and
do it
then
2 times what? 2 times 6, 3 times a 4, and then and a 1 times a 12, obviously, right? And on a 28, I could do 1 times 28, 2 times 14,
7 times 4.
3 times nothing, 4 times 7, and 7 times 4 would just be reversed. Okay, what is the biggest number that they both could be divided by? 4 is what they have in common. It's the biggest number that they both have in common. Therefore, it's the greatest, meaning biggest, common, what they share. Factor, meaning things that multiply together. And so that's what we're looking for today, is greatest common factors. And they're going to be more unique in their appearance than just normal numbers. But that does not make it any harder. It just makes it different. So if you would, look at your notes and recognize that greatest common factor tells you what to look for. Greatest, biggest, common, what they share. Factor is something that could divide into it, right? Two things multiplied together are factors. All right, so if we look at these two terms here, we have the 21 with the xy, and we have the negative 18 with the x squared. Those are my two terms. So if I look at it carefully and think, okay, what is the biggest possible number that 21 and 18 happen to share? What could they both be divided by that's the biggest possible? 7 won't go into 18, but 7 will go into 21. So 7 won't work. It has to divide into both of them.
3.
3. 3 works.
Yeah, 3.
So I think 3 is the biggest. Yeah, good job. Okay. And then, so 3 would be part of what we would consider to be our greatest common factor. You'll see it, greatest common factor. A lot of people will label it GCF just as an abbreviation, okay? Greatest common factor. So 3 so far is the numerical value, but notice that both of these terms have variables as well. Now, greatest means the most that they have in common. How many x's would this term have?
3. Well, 1.
1. How many x's does this term have?
2.
So how many would they actually have in common? 1, right? It's going to be the smallest number on the variables, always. So they share an x, because there's an x here and there's 2 of them here. So they actually share an x. So that's what's in common. Do they both have y values?
No.
I can't say that they have a y in common. So the greatest common factor for these two terms would be 3x. Does that make sense to you?
Mm-hmm.
Biggest number, smallest number of variables that they share. Okay? Now, what we're going to do in this next section is important. Okay? And showing your work is going to be really important. Some of you don't like to show very good work. I'm going to ask you to try to do a much better job showing some work on this section. We're going to find the greatest common factor, just like we did. After we find that greatest common factor, we're going to find the other factor. Because remember, two things multiplied together to get the number are factors? We're going to do that. So I'm going to ask you to show your work exactly like I'm doing it so that you get the hang of how to do it and what it would look like, okay? So let's move now to this try it. And we're going to do something a little bit different. We're going to start by finding the greatest common factor. So look at your values here. I have a 64, a 32, and an 8. What is the largest possible number you can think of? 8. If you're good at your multiplying skills, that's why it's so important to learn your multiplication tables really well. It helps you divide problems out. So if you're good at multiplication, this should be easier for you. Now, I want you to write the 8 down a little bit. I want you to leave some space here, because we're going to come back and use that space in a minute. All right? So 8 is the biggest number that they share. Now let's look at the variables. I have 3 R's, 2 R's, 2 R's. So how many do they share?
2.
The most they share is 2. There's 2 in this one, 2 in this one, and there are 2 in this one, but there's even more than 2. So 2 is the most we can have. So an R squared is going to be part of my greatest common factor. How about the S's?
S1.
S1, because there's a 1 here, a 3 here, and a 2 here. They don't all have 3 of them, so I can't say 3. But they all have 1 of them for sure, so an S. That is the greatest common factor. We are now going to find this times this. These would be 2 factors, right? Something times something else. The way we find this is we divide our original problem by the greatest common factor. 8R squared S, 8R squared S, 8R squared S. That's why I wanted you to leave some space. You're going to divide each term by the 8R squared S. So let's, pardon me? Talk to me.
Why are you doing 3 times 8?
Because I'm putting them right underneath each other so I can visually see it better. Okay? I'm just doing it for a visual. It's a great question, okay? Yes,
I
sir.
can remember for the variables you have to subtract since you're dividing.
Very good. Yes, we're going to subtract our exponents because we are now dividing these. So 64 divided by 8 leaves you with 8. R to the 3 divided by R to the 2 leaves you with just an R to the 1. S to the 1 divided by S to the 1 goes away. There are no S's left. They turn into a 1. Moving to the next term. Negative 32 divided by 8 is a negative 4. R squared turn into a 1. S to the 3 and S to the 1 turn into S to the 2. Okay. 8 divided by 8 is a 1. R squared is a 1. S squared, S to the 1 leaves me with just a S. Okay, what you now have are 2 factors that if I were to multiply these together using the distributive property once again, would build my original problem. So you can always check to see if you're right by actually working your answer out. You get your original problem back. Let's see if it works. See if you did good. I've only had 1 cup of coffee so far. All right, so 8 times 8, 64. R squared, R to the 1, makes R to the 3. S to the 1, no other S's, gives me S to the 1. I got that first term back, didn't I? Moving to the second term. 8 times negative 4 is a negative 32. R to the 2, there are no R's here, so yes, it just stays. S to the 1, S to the 2. Aha, I did get the S to the 3. Moving to the last term, 8 times no other numbers leaves me with an 8. R squared times no other R's leaves me with an R squared. And S to the 1 times S to the 1 makes S to the 2. See how I got my original problem back? It's not any different than me saying, okay, 12 was my original problem, and I decided that I had 2 times 6. Well, if you multiply these 2 factors together, don't you get your original problem back? It's the exact same thing, just on a bigger scale with letters and stuff, okay? Any questions so far? Feeling kind of okay with this? Fantastic. See if you can find the greatest common factor first, and let's make sure we have that part right, and then we'll find our other factors, okay? So, look at the numbers first. What's the biggest number that they all share? An 8. Very good. Do they all share a variable in common? No. And that's okay. So we're saying, okay, the only thing we have is the number 8 is the greatest common factor so far. So we're now going to divide by 8. And our answer is going to go into the parentheses. 16 divided by 8 is a 2. There were no x's or y's, so I can just drop everything down. 32 divided by 8 is a 4. And then I bring the x down. Then 8 divided by 8 is a 1, leaving me with just the letter y. Did you do okay? Okay.
Is this required on our homework to do?
I'm going to say yes in the beginning. I am going to say yes because it's going to get, if you don't start out right, you're going to be very confused. Okay, so let's try to show good work in the very beginning, and then once you understand the pattern, I'll let you kind of take off and do more your own thing. Okay?
Can you do y instead of just y?
Yeah, you could put a 1. You could put a 1 in front of the y. That's not a problem at all. Okay. What if, yes? Any other question? No? Okay. What about this one?
The greatest common factor would be a 1, basically. What it is.
The numerical greatest common factor would be a 1. But do we have something else?
Yeah.
A b. They have a b, right? That's fine. You can use a letter as the greatest common factor if that's what it is. Okay, so if I divide this out, and if you want to put a 1 there, you're correct, Jay. 1 is the greatest common factor as far as an actual numerical value. So if I divide this, I'm left with an A. If I divide this, I'm left with a 7. And so notice, you can have a variable alone as a greatest common factor. You can have a number or constant as a greatest common factor, or you can even have a combination of numbers and variables. There are no rules. It's whatever works. We good with that idea? All right. Now sit tight. This is really easy. Do not make it hard. It looks complicated. All right. This next section is going to ask you to find the greatest common factor and put it out in front. And then whatever's left over creates your second set of parentheses. Now remember, a factor is two things. Factors are things that are multiplied together, right? Sometimes we have factors that are they're staring us in the face, but they're not just a monomial. They might be binomials. They might have 2 terms inside them. And if we look at this particular problem right here, m times the quantity 2n plus 6 minus 3 times the quantity 2n plus 6. Do you see something that each of those terms has in common?
The inside the parentheses.
Right, the 2n plus 6 is the greatest common factor. This thing has it, and this thing has it. So if that's going to be my greatest common factor, I'm going to pull it out to the front. So here it is pulled out to the front. And then notice that this is a set of parentheses times another set of parentheses. Well, how did they get this answer?
Because it was...
They divided by the 2n plus 6. Notice if I divide by itself, this whole thing cancels out to make a 1, and the only thing that's left is the letter m. If I divide this by the 2n plus 6, it cancels out, and the only thing left is a negative 3. So m minus 3 created that second set of parentheses. See how that kind of worked? So let's practice that. Let's leave a space again when we're working down here. Leave a space. What is the greatest common factor of this first try it here?
A minus 1.
A minus 1. So I'm going to leave a space and drop it down and put a minus 1 in parentheses times my answer after I divide by my greatest common factor, which is going to be a
4 plus
4 plus a b.
Can't you just drop down then?
Yes, but we're just learning, so let's show our work, and it'll help us with our pattern of how do I get what goes in that second set of parentheses, okay? So yeah, I'm being a little bit grumpy about that, but just in the beginning, okay? How about that second problem now?
Is that
B.
the final answer?
Yes, this is your final answer because you have something times something else. These two factors, if you were to multiply all this mess together, you would get an answer that could turn into this first original problem. Okay? So this would be considered to be factored all the way. Because if you FOIL this, you could create that answer in here. Okay? How about this one?
B minus 6.
B minus 6 is going to be the greatest common factor in the first set.
And then the second set, 6a minus 4.
Good. Yep. So that goes away, and I'm left with a 6a and a negative 4. So it's kind of easy when it's set up like that, right?
You know what color does it?
Okay. Now, here's the deal. We're going to do something that looks complicated, and we're going to turn it into looking like this. Once it looks like this, then isn't it easier to finish? So that's what we're going to do. We're going to take something complicated, turn it into looking like this, and then it'll be easy for us to finish. Your final answer should always be two things truly multiplied together. Two or more things. Okay? All right, so I'm totally not going to do this. Please rewrite this problem over here on the right-hand side. This 2x squared. We'll have plenty of room if you do this. 2x squared plus x minus 8x minus 4. All right. What is different
They're out of the parentheses.
is there are no parentheses, right? And look at what the directions are actually asking you. It says factor by grouping. By grouping. What do you think that probably means?
You gotta group all the factors.
We're going to have to group them. They're not grouped. We're going to group them. And essentially, if you have four things, what makes common sense to group them into?
2.
Two groups, right? Split them. You're going to draw a line right after the first two terms, right there. And I am going to beg you to draw the line. It makes a difference. It helps. Okay? Now we're going to work each of these sections separately and do what we've been doing. What is the greatest common factor of this first half?
It's 2.
So whatever you decide for this first half, they have to have in common. Do they both share a 2?
No.
No, an exponent 2 is different than the coefficient of 2. So they really don't have a numerical value in common, do they?
So,
But do they have a variable in common? X. And it's x to the first power. They both have to have it, okay? So leave a little bit of a space. So the greatest common factor of this front half is an x. We're going to now build what goes next by dividing, just like we did before, by our greatest common factor. So this will be a 2 with an x, and x divided by x is a 1. You see it?
Yep.
You okay with it?
Wait.
Uh-huh.
Okay.
Talk to me. It's just like we did before. We're just pretending this part doesn't exist. We're looking for a greatest common factor, and we're dividing it out to get our remaining leftovers.
So the x's after that x, so they don't cancel out.
They do. They turn into a 1. A number divided by itself is a 1. 5 divided by 5 is 1. Right? So x divided by x is also 1.
Is like the
So
x.
why isn't it in the
Right. Yeah, that's a great way to look at it too, Jack.
so why isn't it in the first problem like the one above it?
Talk
Why isn't there one in
here.
yeah?
I did not have matching. This
Oh, okay.
this is a 1. That it did cancel out. And what is negative 4 times 1? Negative 4. It did turn into a 1. Okay? Okay?
Okay.
All right.
So,
Yes, sir. Talk
why'd
to
you
me.
divide it by x?
Because
How'd you get x on the outside?
because x is the greatest common factor in
okay.
between the two terms, okay? Great questions. Keep asking till you're comfortable. This is important. You good? All right. Now, we're going to move over to this side and find the greatest common factor from this half.
But
It could be a -4, it could be a +4, right? We don't really know. Do you see that? Okay, here's what helps you determine that. You're hoping to get the two sets of parentheses to match perfectly. So at this point, we know there is a 4 as the greatest common factor. So if I were to divide by a +4, would I get a +1?
no.
No, so it needs to be a -4, so I'm going to put a negative in front of that 4.
2x.
I would negative 2x.
Negative divided by negative is a positive
Oh, okay.
2x. Good job. And then a -4 divided by a -4 is a
Positive.
+1. So see how I treated them separately and really ignored them completely?
Yep.
But notice that these two are not multiplied side by side because we were just finding greatest common factors during this and taking them separately. But now, do you see the common factor?
Yep.
So now we're going to have our final answer as two factors multiplied together. So the greatest common factor of this problem right now is a 2x plus 1. So if I divide this term by the 2x plus 1, so that turns into a 1. And then a 2x plus 1 here, that turns into a 1. My greatest common factor went here, and what was left over after I divided?
X minus 4.
X minus 4. Final answer. Notice two terms multiplied together.
So if it's a negative variable, will it always have like a negative whatever divided?
It's just one of those things you kind of have to sort of guess and check. Just make sure. Ultimately, your goal is to make these two sets of parentheses match so that they can then become your common factor. Okay? So if you have to make something negative, do it. It's up to you. All right? And the only thing that would change is this might have been a -4 or this might have been a +4. So it's just the term that's right in front of the term. Okay? And as we practice these, you'll get better at it. Okay? All right, let's look at the first triad here at the bottom. Because we basically went through those notes now. I just liked us working together. I think we did a better job. So what are we going to do? We're going to split this in half, right? So I'm going to draw a line right behind the A.
Greatest common factor would be
And A is part of it.
3A.
A 3 with an A. So I'm going to leave a space. The 3 and the A are the greatest common factors. So I'm going to divide to find what belongs in the parentheses. So the 3's cancel out, and that leaves me with a single value of A. That'll be a -1, because 3A divided by 3A becomes a 1, and it was negative, correct?
Yep.
All right?
You know it's a -3. Wait,
Okay. We're going to get there. All right. Now, on the second half,
4.
a 4. So we think it's going to be a 4, right?
Yes.
We're going to test it and see, because remember, we want our sets of parentheses to match. All right? So if I say 4 divided by 4, I'm going to get a, uh-oh.
So a negative 4.
So I probably should use a -4 so that I get a -1. You see that? Because I'm wanting these to match. And if I divide this, I'm going to get a +4. So I'm going to change this to a -4 as my greatest common factor. Now, if I divide right here, I get a -1. If I divide right here, negative divided by a negative is a positive
Plus.
A. Does it matter what order they're in?
No.
As long as, look, this is a positive A, this is a positive A, this is a -1, this is a -1. I'm just going to rewrite it to match this one. Okay? I didn't change their values, I'm just rearranging them. You okay with this? Okay, so the A was positive and the 1 was negative. I have one last step to do, and then I can call it good.
Which is
That's right. So what would you have?
a minus 1 in first parentheses, and then second parentheses is 3a minus 4.
Perfect. Final answer. Right, Dad? You need to be writing some stuff down here. Okay? Come on, guys. This is huge for the next 2 years. I'm not playing with this. That's why I'm actually taking it very slow. Have you noticed?
Yep.
I need you to ask questions, and I need you to understand this. If you don't, you're going to be sunk for the next 2 years. And this doesn't get easier. This is the beginning. All right. So let's look at this last one.
So
Where are you going to divide it at?
the middle.
Right behind this x squared, right? Okay.
So the greatest common factor would be 4 with
A 4 with
x.
how many x's?
Well,
Two.
yeah, x squared, 3.
Two.
Think it
Two.
through. Okay, there would be 3 here. There would be 2 here. There's 2 here and at least 2 here. So 2 is what they would have in common. Okay? So I would divide by a 4x to the second power. So that cancels out and I'm left with an x. Negative 20 divided by 4 is a negative 5, and the x is canceled out. That went that well. Moving to the other side, a 3. I'm going to make the assumption that it's a positive 3. I may have to change that, though, when I do my math. I don't know, because I need a negative 5, right? We're trying to make them match. Is that going to turn out good? Yes, so I'm good. So it's a positive 3. They cancel out. I get an x minus a 5. Almost finished. Simplify that. X minus 5
4x.
times 4x squared plus 3. How you doing? Pretty good?
Yep.
Okay, we are not going to address the back of the notes today. We'll eventually get to that, and I'm going to also adjust your assignment slightly. In a good way.
Okay.
Okay. Now, I'm going to ask you one question, though. What would happen if I had given you a problem that looked like this?
You would have what?
Oh, you're killing me here.
That's pretty funny. You could. You'd skip it.
That's what
Okay, what happens if I would have asked you to factor that?
divide.
None of them have anything in common.
Not in the order in which they are. Good job. Not in the order in which they are. Okay? If I do this, nothing works. If I do this, nothing works. But if I were to rearrange them, put the 5y over here with the negative 25, could I now split them in half and factor them properly?
Yes.
Yes. So you are allowed to do that. I believe problem 29 is going to make you do that. So
Can we work on this tomorrow too?
I won't see you tomorrow.
Oh, I thought we were in this class tomorrow.
Well, no, I will see you tomorrow, but not for mathematics.
Yeah. but like-
No. No, we have activities that we are required to do. So,
Oh, my bad.
okay. So let's adjust your assignment. Shh. Guys. Shh. We're going to cross off the 44 and change it to a 38. So 23 to 38 every third. Cross off number 50. And then 68 to 73 all. Okay? I think it's 12 problems. Okay. You've got some time to start today. Ask for some help if you need it.
I
Yes?
would check to see if I have any bugs. So
Okay. So, let me know if you need some help. Work on it as much as you can. Don't be messing around. No, you cannot listen to music on your phone.
Alright.
Sorry about